This is the key for the chapter 5 and 6, or module 5 and 6 review. So the four types of polynomial and behavior are, as x approaches positive infinity, y approaches positive infinity, and as x approaches negative infinity, y approaches positive infinity. This happens when the leading coefficient is positive and the degree is even. You can also have where x approaches positive infinity, y approaches positive infinity, x approaches negative infinity, y approaches negative infinity. This happens when the leading coefficient is positive, but the degree is odd. You can also have happen where x approaches positive infinity, y approaches negative infinity, x approaches negative infinity, y approaches negative infinity. This happens when the leading coefficient is negative and the degree is even. And then the last situation is where x approaches positive infinity, y approaches negative infinity, x approaches negative infinity, y approaches positive infinity. This happens when the leading coefficient is negative and the degree is odd. So, if I look at my situation, this polynomial, I notice that the leading coefficient is negative, and then I have 2x's, 3x's, 4x's, 5x's. So my degree is odd. So I have, in fact, this situation. Alright, so how do I find the x-intercepts for a polynomial? Well, I just take my polynomial in factored form and set each piece equal to 0. So in this case, I have x minus 1 squared equal to 0, x plus 2 equal to 0, x minus 3 equal to 0, and x plus 5 equal to 0. And you might have asked what happened to negative 3. Well, if I set negative 3 equal to 0, I get no solution from that part, so I just ignored it. So this one, we get negative 5, we get positive 3, we get negative 2. This one, I guess we technically can split it twice, and we get the solution x equals 1 twice. So my x-intercepts are 1, negative 2, 3, and negative 5. So, if I plotted these, already I would know there's negative 5, there's negative 2, there's 1, and there's 3. And because of my end behavior, I know that x approaches positive infinity, y approaches negative infinity. So I have the right endpoints down. As x approaches negative infinity, y approaches positive infinity. So I know the left endpoints are. What I need to know is what's happening in between those. That's what the sign diagram is going to tell me, is whether my graph is above or below the x-axis for each of these pieces. So the intervals that I'm concerned with are from negative 5 to negative 2. That's this interval. And then from negative 2 to positive 1. That's this interval. And then from positive 1 to positive 3. That's this interval. And then I'll just make a spot for each of them, each of my factors from my polynomial f of x. I'm just looking at this again up here. And then we look at the whole thing. So, if I fill this in, negative 3, well, that's always negative, no matter what the value of x is. X minus 1 squared is always positive, regardless of the what the sign of x is because it's squared. Now for the next 3 here, we're going to depend on the x's that we pick. So from -5 to -2, I'm going to pick a test value. Let's say -3. I plug -3. -3 plus 2 is negative. -3 minus 3 is negative. -3 plus 5 is positive. I have 3 negatives, so that is negative. From -2 to 1, I'll pick a test value. Maybe that test value is 0. 0 plus 2 is positive. 0 minus 3 is negative. 0 plus 5 is positive. We have 2 negatives, so that's positive. And then our last interval is from 1 to 3. I'll pick a test value there. Let's say 2. 2 plus 2 is positive. 2 minus 3 is negative. 2 plus 5 is positive. So here we have 2 negatives. So again, we have a positive. So if I look at that, from -5 to -2, we should be below the x-axis. From -2 to +1, we should be above. And from 1 to 3, we should also be above. So there we go. The next one asks us to simplify each polynomial. So the operation that I'm doing becomes really important here. Notice the first expression is just adding and subtracting. So when there's addition, I can just kind of ignore any parentheses. So I have 3x cubed plus 5x minus 3 plus, well, instead of writing plus negative, I'll just write minus. I'm just writing that one down. And then we'll just distribute this -5 through. So it's -10x to the 4th plus x plus 30x squared. So if I combine these, I have a -10x to the 4th and another -10x to the 4th, so that's -20x to the 4th. I have a 3x to the 3rd. There's no more x to the 3rds. Oh, I lied. There is another one right there. So I have 11x to the 3rd. And then I have -6x squared plus 30x squared gives me 24x squareds. And then I have 5x minus 4x is 1x plus 1 more x is 2x. And then I have -3, +3, those give me 0. So this is my final answer there. For part B, we're multiplying. So when I multiply this, I'm going to choose to do the box method here. So I have 5x to the 4th minus 3x to the 4th. Oops, that's 5x to the 5th. 3x to the 4th. Oh, no x cubed, so put a 0 there. 7x squared minus 5x, and then plus 1. And down the side, we're going to have 3x cubed, 0x squared. Ooh, almost forgot that one. 6x, and then a 2. So right away I can fill in my 0 columns and 0 rows. And then we'll just continue. 3 times 5 is 15. X cubed times x to the 5th is x to the 8. And so on and so forth. And magically I'm done. So, to now get my answer out of this, I'm just going to add up along the diagonal. So 15x to the 4th, 15x to the 8th. And in my x diagonal, I get -7x to the 9th. negative 9x to the 7th. And then I add up along that diagonal, and I get 30x to the 6th. And I kind of keep on going. And once I've combined those all together, I get 15x to the 8th, minus 9x to the 7th, plus 30x to the 6th, plus 13x to the 5th, minus 21x to the 4th, plus 45x to the 3rd, minus 16x squared, minus 4x plus 2. Now to do the division problem, notice that there are two types of division. I can do long division and synthetic division. Since my divisor is not monic, I'm forced to do the long division. So I'll copy this down. Notice again I have no x cubed, so I'm going to write in a 0x cubed term. And I'm going to ask myself, what times x squared gives me 3x to the 5th? Well, that's 3x cubed. And I multiply that to each piece of my divisor. And then I subtract down. Gives me 0, gives me negative 4x to the 4th, and negative 3x cubed. And then I bring the x squared down, and I repeat and ask myself, what times x squared gives me negative 4x to the 4th? That's negative 4x squared. So I have negative 4x to the 4th minus 8x cubed minus 4x squared, and I subtract all that from above. So I get 5x to the 3rd plus 5x squared, and I bring the 4x down. And then what goes into x squared that gives me 5x to the 3rd? Well, that's 5x. I multiply that to each piece, 5x cubed plus 10x squared plus 5x. And then I subtract down 0, negative 5x squared minus x, and then I bring that 1 all the way down. And then I ask myself, what times x squared gives me negative 5x squared? Well, negative 5. And then subtract down, I get 0, 9x plus 10. And then if I say what times x squared gives me 9x, not a polynomial, so I'd say my remainder then is x plus 9x plus 10. So the way I'll write my final answer, I'd say 3x to the 3rd minus 4x squared plus 5x minus 5 plus my remainder, 9x plus 10 over my divisor, x squared plus 2x plus 1. The next problem is also a division problem, but this time if I look at my divisor, I notice that this guy is a monic polynomial, so I can do synthetic division, and that's much faster, so I'm going to do that. I'm going to start by setting x minus 5 equal to 0 and solving that. And I do that, I get 5, and that's what I put on the outside. And then I do the coefficients. Notice that I have x to the 5th, but I have no x to the 4th, so I got to put a 0 there. Cannot forget to do that. You will get the incorrect answer if you do. So we start by bringing the first number down, we multiply and then add down. 5 times 97, gads, that's 485. And then 5 times 481, oh my gosh, who can do that? It's 2005. And I add the 6 to that, and I'm going to get 2411. 5 times 2411 gives me 12,055. If I add that, that's 12,066. So, what this tells me, my remainder, my constant, my x squared, my x to the 3rd, and my x to the 4th. So So my answer here then is x to the 4th plus 20x cubed plus 97x squared plus 481x plus 241 plus 12,066 over x minus 5. This next problem, part E, is a binomial theorem problem. So to do this, we just apply the binomial theorem. 5 choose 0, a to the 5th times b to the 0 plus, and then 5 choose 1, 2x to the 4th, negative 5 to the 1st, and we continue on using that same pattern, and we get this. What I need to do now is I need to evaluate these on my calculator. To evaluate these combinations, the easiest way is to use your graphing calculator. The graphing calculator has that combination button built into it. So what I'm going to do is I'm going to do math over to the probability menu and then pick the NCR command. I'm going to start with 5, choose 0, and then I need a 2 to the 5th. Notice here, because the coefficient on my x is 2. And then I'm going to have times, and then negative 5 to the 0. So that gives me that my first coefficient is going to be 32. And the x part of it is x to the 5th. And now I'll continue doing this. So the next time I'm going to press second and enter and just do a little updating. So the exponent on the 5th has become 1. So the exponent on the negative 5 is now 1. The exponent on the 2 is now 4. And the subscript on the combination is now 1. So I update those and press enter, and I get negative 400. And this is x to the 4th. And I'll just continue doing this in the same fashion until I continue doing this until we get our final answer, which is 32x to the 5th minus 400x to the 4th plus 2000x to the 3rd minus 5000x squared plus 6250x minus 3125. The next kind of problems are these factor completely problems. So the first thing I do is look for a greatest common factor. I notice between 48 and 243 there is something in common. 48 has a 3 in it, and so does 243. So I can take a 3 out. And also there's an x squared in common. So when I take 3 divided by 48, I get 16, and then x to the 4ths minus, and then 243 divided by 3 is 81. And this piece now has 2 terms. So I notice that this is a difference of 2 squares. I can write that as 4x squared minus 9 times 4x squared plus 9. But I'm not done. I have to check each one of these 2 factors to see if they can factor. Well, if I start with 4x to the 4th, or 4x squared minus 9, that is also a difference of 2 squares. I can factor that. That's 2x minus 3, 2x plus 3. And if I try to factor 4x squared plus 9, you might think it factors, but it's not a difference of 2 squares. It's a sum. And sum of squares don't factor, so there's nothing else I can do with that piece. It'll come down to the end. Am I finished? Maybe. Maybe not. I still need to check to see if these 2 factors can factor anymore. I see that they're both linear, so they're not. So this is my final answer here. For part B, I will first observe that each of the coefficients has a factor 5 in it, so I can take the greatest common factor of 5 out. It's going to give me x to the fourth minus 13 x squared plus 180 divided by 5 is 36. And this has 3 factors. So I notice that this can factor like a quadratic. So I need to find 2 numbers and multiply to give me 1 times 36. And then add to give me negative 13. Those 2 numbers are negative 4 and negative 9. So if I do that, x to the fourth minus 9x plus negative 4x plus 36. And I make myself 2 groups. From the first group, I can take out, ooh, look at this, Mr. Kulik made a big mistake. It's an easy mistake to make. Notice I have negative 13x squared here. Those have to be x squareds, negative 9x squared, negative 4x squared, because I still have to add up to give me negative 13x squared. Ooh, almost made a big one. Okay. From the first group, we can take out an x squared. And that leaves me with x squared minus 9. From the second group, I can take out a negative 4. And that also leaves me with an x squared minus 9. So I have 5 times x squared minus 9 times x squared minus 4. Am I done? No. I need to check to see if any of these factors also factor. Well, x squared minus 9, that's 2 terms, and it's certainly a difference of 2 squares, so I can factor that into x minus 3 times x plus 3. And x squared minus 4, also 2 terms, also a difference of 2 squares, x minus 2, x plus 2. So this is my final answer. Now on to part C. Again, I'll start by looking for a greatest common factor. I see that there is a 5x squared in common with each piece. When I take that out, that gives me a 2x to the third plus 5x squared minus 2x minus 5. And that piece has 4 terms. Factoring 4 terms, I use factor by grouping. So I notice in the first group, we could take out a x squared from the second group. I can take out a negative 1. And that's going to give me 5x squared times 2x plus 5 times x squared minus 1. Am I done? Maybe, but maybe not. We got to check to see if these things factor. 2x plus 5, linear, doesn't factor anymore. X squared minus 1, that's a difference of 2 squares. Whoops, a doozy. So that becomes x plus 1, x minus 1. And now I'm done. X plus 1 and x minus 1 are both linear terms, so they can't factor. Next up is part D. Again, I see I have 4 terms, so I'm going to try to factor this by grouping. I notice that there is no greatest common factor here. So I'm just going to make my 2 groups. So notice that I needed to have a plus sign in the middle, so instead of writing it as minus x squared, I wrote it as plus a negative x squared. From the first group, I can take out an x squared. That leaves me with x cubed minus 25. And then from the second group, x cubed minus 25. Oh. Oh dear. Look at what this I wrote here. Look at what's here. Just a daisy. So I can take out an x cubed. That's even with x squared minus 25. That makes much more sense. From the second group, I can take out a negative 1. X squared minus 25, so that's going to give me x squared minus 25, x cubed minus 1. So that x squared minus 25 factors to x plus 5, x minus 5. X cubed minus 1 is a difference of 2 cubes. So remember your sum and difference of 2 cubes factoring patterns. You should, because you will need to remember them. So for this, my a is clearly x and my b is just 1, because x cubed is just x cubed and 1 cubed is just 1. So I have x minus 1 times x squared plus x plus 1. And then I just need to check to see if any of these things are factorable, not factorable, not factorable, not factorable, all because they're linear. Not factorable because there's not two numbers that multiply to give me 1 and add to give me 1. At least not two integers. So we're all done here. And E is my final. Here we're told that x plus 1 is a factor. So we'll start by using synthetic division to divide that off. Let's see what else I get. So just using the same synthetic division process that we had used before. Oh dear, did I make a typo on this? I must have here. I was correct that this was a typo. I meant that to be 35. I'll change that on your sheet so you won't actually even see that typo. And when I do that, I get negative 35 here. I get 0. For this factoring to be correct, for this to work, you have to be getting a 0 remainder when you do your synthetic division. What that tells us is that x cubed plus 13x plus 47x plus 25 is equal to x plus 5 times remainder 0, and then x squared 12x plus 35. And I recognize this part at the end. That factors. The two numbers that add to give me 12 and multiply to give me 13 are 7 and 5. So I can just say x plus 1 is x plus 5 times x plus 7. And that's my final answer. Alright, part A says a biologist has found the number of branches on a certain rare tree can be modeled by the polynomial v of y equals 4y cubed plus y, where y is the number of years after the tree reaches a height of 6 feet. And the number of leaves on each branch can be modeled by the polynomial L of y equals 2x cubed plus 3x squared plus y. Write a polynomial describing the total number of leaves on the tree. Well, I know that if I say the total number of leaves on the tree is going to be the number of branches times the number of leaves on each branch. So when I do that, I just have 4y cubed times, or plus y times 2y cubed plus 3y squared plus y. And just to be different, I'll do like a FOIL thing on this. Multiply everything to the first piece. I get 8a to the 6th plus 12y to the 5th plus 4y to the 4th. And then when I do the other piece, I get plus 3y to the 4th, or 2y to the 4th, plus 3y to the 3rd, plus y squared. When I add those all together, I get 8y to the 6th, plus 12y to the 5th, plus 6y to the 4th, plus 3y to the 3rd, plus y squared. That's part I. And then it says, use that polynomial to approximate how many leaves the tree has 2 years after it's 6 feet tall. So since y was the years after it's 6 feet tall, what I really want is just t of 2. So I'm just going to plug 2 in for each of these values of y, and then see what I get when I type that into my calculator. So when I type that all in and I press enter, I get 1,020. So we have 1,020 leaves on our tree. For part B, or question B, it says a machine that makes a part used in cars has a 2% probability of producing a part outside acceptable tolerance levels. That machine makes 25 parts per hour. Find the probability the machine will make 12 acceptable parts in the hour. Okay, so this is a binomial experiment problem. Remember the binomial experiment, the probability of x being equal to r is equal to n choose r, p p to the r times q to the n minus r, where this lowercase p, this is a capital P, the lowercase p is the probability of success, and q is the probability of failure. In this case, our probability of failure, we're told, is 2%, and the probability of success then would be whatever's left over, 0.98%. So for part I, we want p that x equals 18. So we have 25. Why 25? Because we know that there's 25 parts made an hour. Choose 18 times 0.98 to the 18 times 0.2 to the 7th. 25 minus 18 is 7. So all I need to do then is type that into my calculator. So now that I've typed that in and I press enter, I get that. So don't be confused by this. This is really just 4.27 times 10 to the negative 7. Not 7, negative 7. It was negative 7. Okay. So that is basically 0.000000. So 6 zeros and then a 427. Or if you want this as a percentage, we'll multiply that by 100, and you'd have 0.0000427%. Any way of representing it is okay there. The next question, we're asked making at least 22 parts. So p of x greater than or equal to 22. So to do that, that's going to be the probability of at least 22 is the probability of that x is 22 plus 23 plus 24 plus 25. So those are all the values that are at least 22. So to do that, I will just do each one of those and add them up. So I'll go to my calculator straight away and type that in. When I typed each one of those in, again, typing them in the same way I did up here, I get that that probability is 99.9%. Jeepers creepers, that's a pretty good process. The last question says that we'll make at most 24 acceptable parts. So at most is x is less than or equal to 24. So to do that, we would have to do p of 0 plus p of 1 plus p of 2 plus all the way up to 24. That looks exhausting. Alternatively, that's the same thing as 1 minus the x is less than, is greater than 24. Well, that's easy. That's just p of x equals 25. So let's do that instead. So I'll just go to my calculator. 1 minus, and then p of 25 is 25. Choose 25 times 0.98 to the 25th times 0.02 to the 0. Didn't really need to type that since 0.021 to the 0 is 1. So that is 39.7%. And finally, our last question. A piece of rectangular marble is cut for a new sculpture. You want its length to be 4 times its height and its width to be 2 times its height. You want to have that marble to have a volume of 64 cubic centimeters. So we'll start by sketching a picture. So I'm showing off my art skills here for you guys. So we'll have length, width, and height. Well, probably makes more sense to put those there. And it says that the length to be 4 times its height, and its width to be 2 times its height. That's part I. That's a well-labeled picture. Part 2 says write a polynomial for this. Well, we know volume for a rectangular solid is length times width times height. So I know 64 is equal to length times width times height. But to solve this, I need it in terms of one variable. So I know length I can write in terms of heights. Widths I can write in terms of heights. Oops. And height is already in terms of height. So I can just say 64 is equal to 8h cubed. And then for part 3, we'll just solve that. So I'll divide both sides by 8. And then we'll cube root each side. So I get that h is 2. And from that, then I can tell you that the length then is 4 times 2 or 8. And the width is 2 times 2 or 4. And that's it. Good luck.